So we will start from the point that we have left on the last time. So quickly revise what we have done on the last time. So on the last time we introduced you a topic that is inheritance. This is one of the major characteristic or major property of a object oriented programming language. Suppose when we say object oriented programming languages, it consists of three different characteristics. First, it should consist of class and objects. Second, it should incorporate inheritance. Third, it should provide dynamic binding. And in C++, it's through a polymorphic variable or a late binding. So dynamic binding, late binding, or through a polymorphic variable. That's the point that we are going to discuss. So right now we are talking about the second thing, that is inheritance. So what is the inheritance? Why we are going to use it, and how it is useful? So this is a topic. These topics that we are going to discuss in this lecture. So we have already discussed about what and why. How we are now discussing it. So quickly come to the slide. That is a uh, advantages. So why we need a inheritance? It provides us code reusability. Means something that is written you can use as it is and customize according to the need of current program. Now increasing program reliability, it's another term. Means if you are using something that is already there, checked, tested, debugged, and free from bugs, so if you're using that thing, the code, your code is also reliable. So you are not modifying a major chunk of a problem. You are only just typing few lines of code and using existing library functions. So that is means your programs are much more reliable in comparison to a standalone program written from a scratch. So it's a better problem solving and program design. So design is very clean, and solving here it doesn't mean you don't have to do it. You have to do a work there, but it's help in problem solving, because most of the time you may find existing classes that are suitable for your program. The next point is that it's supporting polymorphism. So when we talk about dynamic binding, so dynamic binding is somewhat related to inheritance. So we will discuss when we talk about the abstract classes and virtual functions. So this is all the example I just told you. It was a like circle. So circle is a round in shape. Now what's the relation between circle and sphere? So if you have a class for a circle, you can also write a class for a sphere based on a class circle. So look at this, two different functions. Suppose I am interested in calculating the area of a circle. Now I am interested in calculating area of a sphere. So if I am interested in calculating area of a sphere, I may use the area of a circle that is written before for calculating the area of a sphere. I can compute volume. Volume again is somewhat related to area. So something that has been computed, it's already there. I multiplied by r into 4 by 3. So that's way means what is this? Circle scope resolution area coming from a circle class. So used in a sphere class. Circle scope resolution area again coming from a circle class, used in a that's a sphere class for computing volume. So means what we are doing, our sphere class somewhat related to our circle. This is already there. So instead of writing sphere from a scratch, I use circle class and add on certain features to form a sphere class. So that's why arrow here means sphere is derived from a circle. The direction of arrow, you tendencies to think is in a reverse direction, but it's the meaning derived from. So sphere is derived from circle. I think we have discussed it. Now we are not going to continue this one. So what are the advantages? Quickly revise. What are the advantages of inheritance? So when we say advantages, there are three major advantages of inheritance. First one is you can reuse methods and data of existing class. So you use existing class, so you use a reusability. You don't have to write, save money and time. You can extend the existing class by adding new data and new method. So you use existing class, add on something to the existing class. It may be in a form of data or method or both of them. You can modify existing class by overloading its method. So means if you are having a existing class, a method is there. For example, in case of a manager and employee, a show method is in a employee. You can also write a show method in a that's a show method in a manager, and you can also call that method from a manager to a employee. So here I am talking about the overloading, but here instead of overloading, we may be using a one more term, that is overriding. That's the meaning that we have already discussed. We have already discussed this thing. So no, just try to revise this again. Suppose I have a class A. What is the class? Class is a blueprint. Remember, it's not a runtime entity. What is a runtime entity? Object of a class is a runtime entity. Now, class is a blueprint, object is a runtime entity, and the member functions and data can be public or private or even protected. Now, suppose what object can access from a class? Object cannot directly access private member of a class. This you know it. For an object, it can only invoke public member functions of a class or a public data. Now, what about that functions within a class? Functions within a class, either public or private, can access both public and private member of a class. So these members can access anything. When we talk about the object, object can only access a public member. Now try to extend this with the inheritance. Now in case of inheritance, so you have a base class. So this is something similar to the previous one. Introduce one more access specifier, that is protected. So you have a private, protected, and public. For now we have an object. Now when we say a private and protected, for a normal class, private and protected exactly same as that of private. So private and protected are basically somewhat private here. So in a base class object, it can access only public member functions, and these protected private member functions can access any of its member function and data when within a class. Now based on base class, you are driving another class. Let's take a drive class. So here all base class is included. You add certain private, protected, and public member functions here. Now you create an object. If you create an object of a drive class, what will happen? It can access public member of its own class or public member functions of a base class. So when this derivation is public, keep in mind when we drive it, either write a public, private, or protected. So when the derivation is public, I can access a public member of a drive class, public members of a base class. Now this is the limit of that's the object of a drive class. It cannot access private and protected member of its own class. So it cannot access a private protected member of a base class. Now when we're talking about the private, protected, and public functions of a base class, they can access public and protected member of a base class, not a private member. So even public, private, protected member of drive class cannot access a private member of base class. So there is a data hiding there even in inheritance. So base class is a part of a drive class, but members are not accessible. Private members are not accessible, and even protected and public member are accessible only through a functions within a drive class. So this is the structure, and you keep in mind this is a way of access. So suppose if it's permitting, it should follow this particular pattern here. Now next topic that we are going to discuss today is about the drive class constructors. Now previous example we have talked about the countdown. fine. What was the countdown? Countdown was the problem that was designed based on a counter. Purpose was to increment and decrement a value. So in a base class, we have increment prefix, increment operation. In the drive class, we have a prefix decrement operator. So in the let's take what was the example. So this was your example that we discussed in a class counter protected. So you have a default argument, you have a one argument constructor, few functions there, and the increment operator, that is prefix. Then you create a drive class countdown with public specifier, and you add a function that is a counter operator. So remember this definition, put it in front of you. So what we are going to discuss based on this particular definition. Now, if we write a statement, what is the statement? Countdown C1 equal to 5. In a previous program, what will happen? Go back to the definition there of a countdown class and tell me what will happen to this one.
Please move to the previous page.
Yes, please bit loud.
Can you move to the previous page?
Let's take. You can have this definition. I have a counter definition in front of you. Check it out. Is this statement a valid statement? So just look at this one. In case of a counter class, we have a arguments, counters without argument, one argument, counter class. And in this case, I have a statement, and this is a class countdown. So what will happen to this statement? Now, come back to the previous things that we have already talked about. Countdown C1 5 equal assigning value of 5. What is required for this particular statement? If you write a object C1 in the you constructed object C1, what is required for this particular statement?
You need a constructor to initialize C1.
Yes, it need a constructor. Is a constructor here?
No, sir.
No. But how in the previous example, I have a countdown C1. It's working. No constructor in the class.
Default constructor is operating there.
Okay, fine. Very good. This is the answer. For this case, I have a default constructor, but I haven't written it. But default constructor is added by a compiler when you don't write any constructor here. But in this example, I am using one argument constructor. Compiler never add a one argument constructor on its own. Compiler only add default constructor and a copy constructor, nothing else. So it does not know how many arguments, so it does not add any one argument constructor. So here one argument constructor is missing. But in case of previous, without 5, default constructor is there. Why? Compiler add that default constructor, and compiler add default constructor, and within default constructor it calls the constructor of a base class. That's why this statement is valid. And now when we add C1 is equals to 5, this is somewhat not a valid statement. So I have to add on something to my class countdown so that I should be able to use this statement in my program. So what we can do to make such definition work, we must write a new set of constructors for the drive class. So I have to add on a few more constructors to my drive class. So let's take what are the drive class constructors. So you have a counter. This is example that we have seen it. So these are the original class, that is a counter class. To this we are going to add a drive class constructors. So class countdown, public counter. Countdown, public counter, publicly driving from counter class. Then you have a public countdown counter. Which one? This is a default constructor. Look at this one. What is this? Is this a initializing variable? It's a countdown zero argument. So it's a default constructor for a countdown. Then you have a initializer list. But in case of initializer list, I am using a function named counter. That is the name of a constructor in a counter, and it's basically invoking constructor of a base class. So initialization list can be used for initializing variables. It can also be used for invoking functions. So I am invoking function counter. This is a constructor or default constructor of a base class. Next is a countdown integer C. So it's a one argument constructor. Here again I am using counter C. So if you look at this one, counter without argument, counter with argument. So it is a one argument constructor of a base class. So here what I am doing, I am creating constructors in a drive class and invoking the corresponding constructor of a base class. So here countdown zero argument constructor of drive class is calling zero argument constructor of a base class. So it's a D, it's a B. Similarly here it's a one argument constructor calling a one argument constructor of a base class. Then you have a countdown operator minus minus return countdown, and it's something similar to the previous example. So this way we are basically what we are doing. I am creating a constructor because I do not have any member function in my drive class. I need to initialize the member function of a base class. So I am passing control to a base class. The function is invoked. A constructor of a base class is invoked. So let's take how to use it. So if you use countdown C1, default constructor is invoked here. So counter is countdown counter is invoked here. So default constructor invoking a counter constructor or a constructor of a base class. Now if you use a countdown C2, what it will do? It will use one argument constructor of a base class, drive class. In turn using a one argument constructor of a base class. Then you are printing the value of C1 and C2. Then incrementing a value of C1 by 3. Then printing a value of a C1. Decrementing a value of C2. Then printing a value of C2. And let's take the third one. Countdown C3 is equals to minus minus C2. Now what is this? And what is the meaning of this statement? Countdown C3 assigning a value of minus minus C2. Which constructor is invoked here? Because I am creating an object C3.
Default
So the
constructor.
constructor with one argument.
Okay, in case of a one argument, the argument is of type integer. It's not of type of object C2.
Copy constructor.
It's a copy constructor basically, and we haven't defined it. But compiler add a default constructor and a copy constructor. when you define any constructor, compiler does not add default constructor, but still it's add a copy constructor. So this is the case of a copy constructor. Copy constructor is invoked. The value of C2, that's a decrement value of C2, is copied to C3. So if you don't have a C3 statement here, countdown here, it was initialized before, then it's an assignment operator. But here it's a creation of object, so it's a copy constructor is used for assigning a value of C2 to C3. So you have a Cout and C3, then you printing the value, return 0, and it's okay. So this way, now get an idea, means how it's working. If you are talking about a drive class, I am using a constructor of a drive class and a constructor of base class. But what should be the order? Which constructor should be invoked first and which constructor should be invoked later? So if you have a class, base class and a drive class, you are invoking constructor of a drive class, and which in turn using a constructor of a base class. So which constructor is executed first?
Constructor of derived one.
Actually, the constructor of drive started, but execution completion of base class is done first. First, it initializes the business. Look at the statement. Countdown in C. So you are initializing a C. You are initializing a C of a base class. So here it will invoke a base class constructor, and then only it will come to the body of a drive class constructor. So actually it's a base class constructor that is invoked first, then a drive class constructor. So means order of execution of a constructor, first a base class, then a drive class. When we're talking about the order of execution of a destructor, so first a destructor of a drive class, then the destructor of a base class. So, and why it's a viable option? Because you are creating an object. Object is based on drive and that's a base class. So first you initialize base class value, because you will be using these values for initialization of a drive class part of a entire class. So here I will be using a base class constructor, invoking a base class constructor and then a drive class constructor. That is why we use it in our initializer list. So it's invoked using our initializer list. I told you, when you something is in an initializer list, it is executed before control is transferred to the body of a function. So next thing that we are going to discuss about overriding member functions. So before this, we have already studied about overloading of a members. So what is overloading? Where you have a same function name with different signature, we call it as a overloading. Like a integer add. No, let's take integer. Let's take some simple example. Let's take show. Show is a function that takes two arguments. Let's take integer a and b. We have another function show that takes three arguments: integer a, integer b, integer c. So name of a function is same, but we are having different number of arguments. Then we call it as a overloading of show, because show have two different parts. One is for two arguments, another is a three argument. But now what is overriding? So overriding in extension, in this case, we have a exactly same signature. So show integer a and b, another function show integer a and b. So we are having two different functions within a same scope, but exactly same signature. When you have a different signature, then we say it's an overloading. But signature is same, then we are going to call it as an overriding. Now, how this is possible? A function with the same name and same set of argument within the same class, and it's going to work. So let's see how it's going to do. So you can use member function in a drive class that override. Now, what's the meaning of this? You can use a member function of a base class. A same member function can be in a drive class also. So means you have a show in a base class, so you can also write a show in a drive class. So here I have a two different definitions. One definition is in a base class, another definition is in a drive class. So I call that type of overloading as an overriding. So here one definition is overridden. So function have the same name as those in the base class. So function in a base class can be overridden in a drive class. Use the scope resolution operator to indicate the member function called are from the base class. So come back to the previous example. This was the example that we have discussed for the inheritance. Area of a circle and area of a sphere. So look at this one. If you write an area of a circle. So here I am talking about a which area. So we are talking about the total area. It consists of area of a circle, area of a sphere. Now here two different area, one area another. This is a qualified to make it known to a compiler that I am talking about the area of a circle. This is corresponding to area of a sphere, and then calculating the complete area of a particular solution. So here I am using two different functions with exactly same signature, but informing the compiler this is present in a drive class, this is present in a base class. So these are the two different instances of a same function. So function named same, but one is associated with drive class, another is associated with a base class. So when you don't use a qualified name, so you're talking about the drive class. Here is a qualified name. I am talking about the area of a base class. So it's a base class member function call. It's a direct member function call of a drive class. So what is there? Must be used internally in the member function of a drive class. So I can use this function within a function of a drive class. So let's see how to use this thing. So writing a program here, hash include iostream namespace process dot and stack. So you have a protected. Why have you used the protected? So I want these members to be visible to my drive class. Enumeration max. So something like max having a value 3. Then you creating a stack of size 3. Integer stack of size 3. You have an integer top public function. So constructor top is equals to -1 to show that stack is empty. Then you have a pushing a variable on a stack. Then you have pop returning a variable from a stack. So let's take this is my definition of a stack. But here there is a problem with this particular stack. Suppose you go on push more than 3 items, then what will happen? This will be the case of overflow. The size of a stack is 3, and if you are pushing more than 3 items, where will the 4th item will go? And this is a problem with my stack. So to eliminate this problem, what I can do, I can create another stack based on this class. So let's take how to do it. So I create another stack, that is stack 2, based on my previous class, that is stack. And in case of a public, I add a function push. Look at this one, previous one, push integer variable. This is a signature, push integer variable. This function is already there in the stack, but I am again writing it. in my stack2 class. So this is a case of overriding. Exactly same signature, nothing difference. Now what I'm doing in this function, I'm checking if top is greater than equal to max minus 1 or not. You're checking out, is it case of a stack is full or not. So if stack is full, I cannot enter, error is stack is full, and this will be presented and your program will terminate. Now this is, if it is not full, what you are doing, I am simply calling stack function of a push function of a stack class. So this is about a base class. So push function of a base class is basically used for this one. So what you can see here means I am overriding it. Overriding means same signature, same name. If a different signature, it's an overloading. Means I have a function stack that is a push. Push is in a base class. Push is also in a drive class with exactly same signature. So I am basically augmenting what is there in a stack class. It is not checking about the range. So I have added a construct to check the range of a stack. If it is possible to add it, I will add it. If it is not possible to add an element to a stack, I simply flag an error. That error is to show that this is stack is full, you cannot enter more elements to a stack. And if it is not full, you can always push. So why to push in a stack here? I simply call a previously written function stack push for pushing a value in a stack there. So that's something that we have added it. So this is about the push. What about the pop? So again, pop is overridden. Exactly same definition in a stack and the same the signature in a stack 2. What we are doing, I am checking is stack is empty or not. If a stack is empty, you cannot pop any element from a stack. If stack is not empty, you can pop it. So what you are doing, I am checking out. It's a -1, is the less than 0. So if it is -1, I'm saying stack is empty and terminating a program. If it is not empty, I simply call a function of a base class for popping the element from a stack. Got it? So here, these two functions are basically the example of a overriding. So in case of overriding, a function is there both in base and drive class with exactly same signature, and most of the time you will be invoking base class function for doing the work there. So either you will be adding something to it, to a base class function using a drive class function there.
Sir,
Yes.
sir, both the overrided function should be in the public part.
Obviously, because these are the functions that will be used by object. Object will be asking for pushing and pop. So if you make them private, this will not be accessible by object. So it does not make any sense. Why? Because your data structure is stack and your object will be STK. So STK will be accessing both push and pop operation. So this should be public function there. Otherwise, this will not be accessible to object outside of a that's a class, or within a main you won't be able to access this function. When you are writing a stack class, the purpose is to add element to a stack and delete element to a stack. To make them private, this will not be possible. So you cannot do add and delete by using an object. So that's something that will create a problem. So that is why you have to make them as a public. Now, let's take an example of this one. So you create a object S1 of type stack2. Now, look at this one. S1 dot push. So first element is pushed. So you can assume this is my stack. So you are pushing 11. Then you push 22. Then you push. $33. What will be the value of top now? Top will become 0, 1, and 2. So the current value of top will be 2. Now, here you are saying S1 dot pop. What will do? It will output 33. Top will become 1. Then it again as pop. It will become it will output 22. Top will become 0. Next statement pop. It will output 11. Top will become -1. Now again you are asking for a pop. Now function invoke pop of a stack 2. What is this function? Pop of a stack 2. So here top is -1 less than. So this will be an error and it will be taken care of it. And this function will not be invoked in this particular case, that is the fourth case. So here this way you will be saving your program for inadvertently changing the value of this particular, because here I have taken a stack here. Now if you have gone to pop, so here maybe some value, let's take XYZ. If you do not put this condition, it may pop up that value, or even it may write using a push operation. So this may create a problem that it may change some variable or some instruction of a program. So that's why I need to put a certain control so that pop does not go beyond its limit. So this way I will be making my code more secure by adding something in a stack 2. If that error condition is not there, I am invoking a function of a base class. Now, the question is that which function is used. So when we say s1 dot push 11, now question is that which function is invoked. The function invoked is of a drive class. So when a same function exists in both base and drive class, the function in the drive class will be executed. So when you say push of a drive class will be executed. It will check that stack is full or not. If stack is full, it will terminate the program. If stack is not full, it invokes a function of a base class, name of a base class and the name of a function, and it will add element in the base class. So for this, what we are doing, a scope resolution with overridden function is used. So why scope resolution? Informing the compiler for the remaining part, use a push function of a base class. So invoking a function of a base class. So I think time is over. So we will continue with our public and private inheritance on the next turn. So do you have any doubt till now? So any doubt?
No, sir.
Okay, fine. So okay, we are going to have a class tomorrow.
Sir, can you please upload the recorded lectures on the classroom after lecture 18th?
Sure, I will do it.
Thank you, sir.